yesterday, or not yesterday, I'm sorry, I misspoke. In the previous class, we learned how to find LCDs, okay, lowest common denominators. So the steps to do that were: step 1, you're going to write the prime factorization of each number. Step 2, for each different prime factor in step 1, you're going to circle the greatest number of times that factor occurs in any one of the factorizations. And then step 3, you just multiply all those numbers together. So I think the best example here is going to be letter C. Okay, so let me get rid of this stuff right here so it doesn't confuse us. And let's see, get rid of this stuff over here so it doesn't confuse us. There we go. So here's letter C. Now notice, all I'm asking for is I want you to find the LCD between 24, 20, and 45. Those are the denominators for each one of my fractions respectively. So first thing I do is step 1, I write the prime factorizations of each of them. So 20 is 2 times 2 times 5. 24 is 2 times 2 times 2 times 3. And then 45 is 3 times 3 times 5. So that was step 1, is just writing out prime factorizations. Step 2 is you're going to look for each different prime number. So I know just by looking at my prime numbers, I have a 2. I'll write it like this: a 2, a 3, and a 5. The question becomes, what prime factorization, or where do I see the most number of 2s? And that occurs in that circled red portion in the number 24. So I have 3 of them. So my LCD so far is going to have, and I'm going to highlight now. So I know my LCD is going to have 3 2s. Now I look at the number 3, and in the number 45, there are 2 3s. That's the most I see in any one number. So my LCD is going to have 2 3s. And then lastly, the number 5. Well, there's a number 5 that appears in 20, and there's only one of them. And then there's a number 5 that appears in 45, and there's only one of them. So it doesn't matter which one I pick. But what I know is my LCD is going to be 3 2s, 2 3s, and a 5, and we multiply them all together to give me 360. So that's how we find lowest common denominators, and that's going to help us. Okay? So today, what we're going to do is we're going to go over this idea of building equivalent fractions. Now, we're going to need to do this, okay, because in the next section, which we're going to see in about 5 minutes, we need to build equivalent fractions in order for us to add 2 fractions together, all right? So the first example here is write 7/8 as an equivalent fraction with a denominator of 56. So here's how we approach this. First, I'm going to write 7/8. Now, the word equivalent means equals. And I want this to equal another fraction where my denominator is 56. Okay? So what I need to figure out is, what is that numerator? Okay, now there are a couple ways we can do this. I think an easy way is the way that we have above, which is in this gold box. And it says to write an equivalent fraction, what you're going to want to do is you're going to multiply the fraction by a very special number. Okay? Now that number, I don't know if you could see it. I'm going to zoom in here a little bit. That number is C over C. Now, we know hopefully C over C equals 1. Just like 5 over 5 equals 1, 8 over 8 equals 1, 2 over 2 equals 1, all right? So, in other words, what we can do is we can multiply a fraction by almost anything we want as long as the numerator and the denominator are the same exact number. Because in reality, what we're really multiplying by is just a 1. So, if I come over into this example here, and I multiply this fraction by 7 over 7, look what happens. First and foremost, 7 over 7 is 1. Nothing changes. Remember, multiplying 1 to any number, you just get the number back. Okay? But more importantly, if you look here, 8 times 7 is 56. And 7 times 7 is 49. So in other words, The equivalent fraction with a denominator of 56, that's equivalent to 7 over 8, is 49 over 56. Does that make sense, everyone? So all I did here is I'm building an equivalent fraction only by multiplying it by a really clever way of writing the number 1. That's it. I wrote the number 1 as 7 over 7. Okay? Does that make sense, everyone?
Yeah.
Okay, so I think I have another one here. So we're going to do this one. So write 1/4 as an equivalent fraction with a denominator of 20. So I'm going to write 1 over 4. And I need to build this equivalent fraction. So I guess the easiest way to think about this, what number times 5, or I'm sorry, I almost gave you the answer. What number times 4 equals 20? What do you think?
5.
Perfect. Now, since 4 times 5 is 20, I also have to multiply the top by 5 as well. Because remember, I don't want to change the fraction 1/4. And the only way I can do that is by multiplying by 1. We were just really clever on how we wrote that number 1. We wrote it as 5 over 5. Does that make sense, everybody? Okay? So here's the last one here. Let's write an equivalent fraction with the given denominator. Okay? So here is my fraction, 9 over 4x. My given denominator is 36x. So what is going to be my numerator then? Any idea? Well, what number times 4 equals 36? Be careful. Who said that? Alexis, what did you say? Or was that Tanisha?
Yes.
Yeah, what did you say again?
I said 9.
Perfect. So I'm going to multiply this fraction by 9 over 9. So 9 times 9 is 81. And 4 times x times 9 is 36x. So that's perfect. So that's how easy it is to build equivalent fractions. Okay? It's just you were just trying to think, okay, what number do I need to multiply by to get me to that number? All right? Now, here comes the good part. Section 5. Oops, sorry. Here we go. So section 5, we're going to be adding and subtracting fractions with unlike denominators. This is the thing that students always have trouble with. So the first thing I want to look at is just an example problem over here to the right. If I wanted to add 1/2 plus 1/3 together, I cannot do this the way it looks right now. Here's why. Here's the fraction 1/2. Here's the fraction 1/3. Notice that although they are the same size, they are broken up in different regions. We need those little regions to be the same, okay? So the only way I can do that is I need to build equivalent fractions by making their denominators the same. All right, now since we just learned that, we're going to go ahead and apply some of those techniques, okay? So for example here, and I'm going to scroll down a little bit. We'll come back to this. We're going to do letter C right here. 2 over 7 plus 8 over 21. And here are the steps directly above. When we are adding or subtracting fractions with unlike denominators, we must find a common denominator. Okay, you got to find that common denominator. And to do this, you're going to follow these steps. Okay, so the first thing we're going to do is find the LCD of the fractions. We're going to build equivalent fractions, and then we're just going to add or subtract. And if we have to, we'll simplify. Okay? So up above, I had 1/2 plus 1/3. And I know this is what they looked like. They did not look the same. Okay? So if I were to quickly do this problem, find the LCD of the fractions, well, first, write the prime factorizations of each. So 2 is a prime number, 3 is a prime number, so there's really nothing I can do. Okay? My LCD is going to be the product of the prime numbers. 2 times 3 equals 6. So here, right here, was just step 1. Find the LCD. Step 2 is to build equivalent fractions. In other words, I'm going to write this, and you'll see where I'm going with this. I need to multiply 1/2 by the number 1 in a very clever way so that the denominator is a 6. The only way I can do that is if I multiply 1/2 by 3/3. Because if you think about it, 2 times 3 is 6. So since 2 times 3 is 6, 1 times 3 is 3. So here's my new fraction right here. I'm going to put a little square around that. Now, I'm going to do the same thing with 1/3. Okay? The only way I can take 1/3 and convert it into an equivalent fraction is to multiply it by 2/2. So 1 times 2 is 2, and 3 times 2 is 6. So notice what I've done is I've taken 1/2 and 1/3, and I made them equivalent fractions. Now, if I were to, let me write this underneath. So 3/6 plus 2/6. Now, if I were to draw these out, they have the same number of blocks. 1, 2, 3, 4, 5, 6. This one has 3 shaded. 1, 2, 3, 4, 5. Okay. And this one has 2 of them shaded. And when I bring them together, I have 5 of them shaded, or 3/6 plus 2/6 is 5/6. Does that make sense, everyone? Now, you're not going to be drawing these boxes in these pictures every time. The only thing I want you to be able to do is steps 1, 2, 3, and 4. Okay? So we'll keep it simple. I don't know what just happened there. Here we go. So 2/7 plus 8/21. Let's do this together. Step 1, find the LCD. So 7 is prime, and 21 equals 3 times 7. So my LCD is going to be the product of the prime numbers, 3 times 7. Notice I have 1 3. That's the most number of 3s I see. I can circle that. And then I have a 7, which I'll just circle that one. So my LCD is going to be 21. Step 2. We're going to build equivalent fractions. All right, so to do this, I'm just going to write 2/7. And I want a denominator of 21. And then I'm going to write 8/21. And I want a denominator of 21. Okay? So, what number times 7 gives me 21? Can somebody tell me?
3.
Good. So, I'll write 3/3. 2 times 3 is 6. So 2/7 is actually 6/21. I'm going to write that off to the right. Plus, now 8/21. You want a denominator of 21. 21 times what number equals 21? Can anybody tell me? It's not a trick question. 21 times what equals 21?
1.
Perfect. So this is going to be 1/1. So this will be an 8. So notice now what you've done is you've built equivalent fractions so that they have the same denominator. And we know when you have the same denominator, all you have to do is add the numerators. That's it. So 6 plus 8 is 14/21. Now, we always got to make sure that our answer is completely simplified. So 14 is really 2 times 7. 21 is really 3 times 7. The 7's reduce. So your answer is 2/3. That is the entire flow of how to do this. Okay? I know it seems like a lot, and it kind of is. Adding fractions with unlike denominators or subtracting fractions with unlike denominators is time consuming. So it's best to have like a system or steps to do this. So if I just zoom out here a little bit, upper left-hand corner of your screen, there are your steps right there. Okay? Step 1, find an LCD. Step 2, build equivalent fractions. Step 3, add or subtract. And then if you have to simplify, you got to simplify. See, earlier in this chapter, I taught you how to multiply and divide fractions first because that's easy. Adding or subtracting is definitely more difficult. All right? So what I'd like you to do now is go ahead and do letter D. 2/5 plus 4/15. Follow the steps, take your time. It's because my mic was muted. I am very sorry about that. So I don't know. I didn't do the problem, but does it look right? Like, do you feel pretty good about it?
I do.
Okay, all right. Well, then let's do it then. All right. So step 1, I'm going to find that LCD. 5 is prime. 15 is 3 times 5. So I know my LCD is going to equal 3 times 5, which is 15. Step 2, let's build those equivalent fractions. 2/5 times something is going to equal a fraction with 15 as my denominator. That's going to be 3/3. So I get 6/15. Then the other one, 4/15. Well, it already has a denominator of 15, so I don't have to do anything there. So I have step 3, which I'm going to add. 6/15 plus 4/15 equals 6 plus 4 over 15, which is 10/15. And I need to reduce. So when I reduce this, 10/15, I'm writing everything out here so everybody sees where I'm getting these numbers from. 10 is 2 times 5. 15 is 3 times 5. The 5's reduce to 2/3. Tanisha, excellent job. Was it that difficult?
No, it was pretty easy.
It's just time consuming and tedious.
Right.
That's really what it boils down to. It's just time consuming and tedious. Now, I know some of us may have add or subtracted fractions before, and you may have done it a little bit of a different way. Like this. I'll write it in blue because I know this is normally taught. How many of us have seen this before? Where you like would write it up top there. Anybody? Just unmute yourself, say yes or no so I can hear.
Yep.
Okay. Although this is a very good method, I don't like this method. And I think the reason why I don't like this is because you don't see why we're building the equivalent fractions. So, Leah, I think that was you that said yes. I can't remember. If you prefer that method, I'm not going to prevent you from doing that. I just want you to understand all the little steps. When you wrote this 5 over 5 thingy here, so I don't know why I scratched it out because I know why, because I got upset because I don't like it. When you wrote this 3 over 3 right here, you were actually doing step 2. You're actually doing that. And you're also skipping step 1, which is trying to find a common denominator. I think step 1 is the hardest part because we always have trouble finding this LCD. So make sure you're writing this stuff out. That's all. That's all I'm going to say is just write things out. Now, when we look at letter E, negative 1/5 plus 9 over 20. Who cares about that negative 1 out front? That doesn't change anything from our technique. So step 1, we're going to find the LCD. So 5 is prime. 20 is 2 times 2 times 5. Okay? So I circle the 2 and the 5 because I see that I have 2 2s and a 5. So my LCD, 2 times 2 times 5 equals 20. Okay? Step 2, let's build those equivalent fractions. So we have negative 1/5. And we want a 20 as a denominator. So the only way to get that is to multiply negative 1/5 times 4 over 4. Negative 1 times 4 is negative 4. Now, the second fraction, 9 over 20, you don't have to worry about this one because it already has a 20 for a denominator. So, you have negative 4 over 20 plus 9 over 20, which is going to be negative 4 plus 9 all over 20, which equals 5 over 20. Correct? 9 minus 4 is 5?
All right.
All right, so now we just need to reduce. 20 is really 4 times 5. Now, you got to remember, the 5's reduce. And when I reduce everything in the numerator or everything in a denominator, what number is still left over?
1.
Excellent. So our final answer is 1/4. Are there any questions? Any questions? Because I feel like I'm moving kind of fast here. All right. We got, let's see here, 3 more problems. That's it, I think. Yeah, 3 more problems. And then we'll move on to the last section. So, 5y over 6 plus 2y over 9. Process doesn't change. Step 1. Let's find the LCD. 6 equals 2 times 3. 9 equals 3 times 3. So my LCD is going to have a 2 and then 2 3s. So my LCD equals 18. Okay? Now, step 2, build equivalent fractions, all right? So the first fraction is 5y over 6. And I need to multiply this by a number so that I get 18 as a denominator. The only number I can pick is 3 over 3. Because 6 times 3 is 18. Now I need to multiply the numerator. 5 times y times 3 is 15y. So there's my, in my step 3, I already know my first fraction. Now I need to do the same thing to the second one. 2y over 9, I'm going to multiply this by a number so that my equivalent fraction has an 18 in the denominator. And the only way to get that is 2 over 2. Because 9 times 2 is 18. So, in the numerator, I get 4y. And there is my step 3. I have a common denominator. So I'm just going to rewrite this. 15y plus 4y over 18 is going to equal 19y over 18. Are there any questions with that? Now remember, step 4 is that reduce. However, 19 is a prime number. So I know that can't be reduced at all. So my answer is just 19y over 18. Does that make sense, everyone? Because I'm not hearing any feedback. So I'm just going to keep going. Next, we have 3 fractions. 5 over 8, 1 over 3, and 1 over 12. Doesn't matter. I can have 2 fractions, 3 fractions, or 50 fractions. I still need to find the LCD. 8 is 2 times 2 times 2. 3 is prime. And 12 is going to be 2 times 2 times 3. So my LCD is going to have a 2 and a 3 in it. The question becomes how many? Well, 8 has 3 2's, so that's the most number of 2's I see. And then 12 or the number 3, they each have 1 3, so it doesn't matter which one you pick. But you're going to have 1 3. So your LCD is going to be 24. Now, I need some space for this next one here, so I'm just going to draw like a little line. Step 2. Build equivalent fractions. I want each one of these fractions to have a 24 in the denominator. Now, the 1/3 was negative, so I make sure I put a negative in front, and the 1/12 was negative as well. So, in red, what am I going to multiply the first fraction by to give me a 24 in the denominator? I'm open to any suggestions.
3.
Good. So it's going to be 3 over 3. So this is going to be 15 over 24. Now the second one, what am I going to multiply 1/3 by to give me 24 in a denominator? Good. So this is going to be negative 8. And then the last one, what am I going to multiply negative 1/12 by to give me 24 in a denominator?
2.
Perfect. So now, for step 3, I have 15 over 24 minus 8 over 24 minus 2 over 24. Since they all have the same denominator, I'm just going to write it as 15 minus 8 minus 2 in the numerator and 24 in my denominator. 15 minus 8, I think, is 7. And 7 minus 2 is 5. So the last thing to do is just check it, see if we need to reduce. In this situation, the 5 is prime. So, and I know 5 and 24, they don't mix at all. So I'm done with 5 over 24. Once again, I'll ask, is this overly difficult?
No.
No, it's just tedious. It takes time. It's one of those things that you just got to deal with. So, the last problem, 5 minus y over 4. Now, this one is a little bit different from the previous ones because that 5 is a whole number. But can I make a whole number a fraction? Is that possible?
Yes.
How do I do that?
Put it over 1.
Perfect. So 5 over 1 minus y over 4. So once again, all you got to do is go through your steps. But I think this one's actually really easy to see, because you need a common denominator of a 4. All right, so the easiest thing we can do here is just take 5 over 1 and just multiply it by 4 over 4 to give us 20 over 4. So when you have 1 as a denominator, the key, or I guess it's not a trick, it's just being able to see it, is whatever that second denominator happens to be. In this case, it's a 4. That's what you're actually going to use. So you can kind of save yourself a little bit of time. So we have 20 over 4 minus y over 4. So now that you have a common denominator, write the numerator. And since you cannot group those two things together, you just leave it like this. 20 minus y divided by 4. And that's it. Are there any questions with what we did?
Wait, why can't you group 20 minus y together?
Because they're two completely different things.
But isn't there always a 1 in front of the y?
This is a rock. This is a pen. In fact, here, let me do it like this. I think this will make more sense. Here we go. We got a rock, and we have 2 blue markers. All right? Can I group these two things together?
No.
No, but if I'm holding this rock, I have at least one rock, correct?
Yeah.
But these are not the same two things. That's if you can think of it that way, even though, and I agree with you 100%, even though there is a 1 in front of that y, it's still the letter y, correct?
Yeah.
And that 20 does not have a y attached to it. So they're not the same thing. Excuse me. So we cannot group those two things together. All right? If we knew what y equaled, Leah, then we could. But we have no idea what y equals, so we just leave it like that. Does that make sense?
Yeah. Thank you.
Yeah, hopefully my marker and rock example kind of made some sense. All right? So are there any questions? All right. So that's it for adding and subtracting fractions with unlike denominators. So the last thing that we're going to do in this chapter, so I got to get my notes out, but what we're going to be doing is solving equations now, containing fractions. So I remember a long time ago, insert printout, there we go. I remember a long time ago, I told you, in fact, it was back here in chapter 3. We'll just go back to chapter 3. How many of us remember these steps here? Steps for solving. If you see parentheses, use a distributive property. Combine any like terms. Do you remember going over this?
Yes.
All right. Now, I remember a long time ago I said, listen, these are the 5 steps, but once we get into fractions, there's going to be an additional step. Okay? And here's where that additional step is. So let me show you. Let me go back to our chapter. And it's actually, we have a new step 1. Okay, and step 1 says that if fractions are present, you're going to multiply both sides of the equation by the LCD of the fractions. And what that does for us, and if you want to, I would definitely write this down. This will eliminate / reduce, however you want to say it, all denominators. Okay? So that's step 1. Will remove all denominators for us. And then if you look, step 2, 3, 4, 5, and 6 are all the same steps that you were used to before. So if you see parentheses, you use a distributive property. Combining like terms on each side of the equation, variable terms on one side, constant terms on the opposite side. Divide both sides of the equation by the number in front, and then check. So the only thing new is that very first step. So when I look at this problem right here, solve, and well, the directions are solved. The problem is x divided by 5 minus x equals 1/5. Okay? So if I look at that problem right there, step 1, if fractions are present, multiply both sides by an LCD. So I look at my denominators right now. The LCD here is going to be the prime factorization of each. Well, they're both the same number. So I know my LCD, no matter what, is going to be 5. So here's what I'm going to do. Please, just watch. Don't write this down yet. Just watch. I'll give you time to write it down. All right, what I'm going to do is I'm going to multiply everything by the number 5. Okay? Now that 5 is my LCD in this situation. Okay? Are we all on the same page so far? Okay, good. Now, here is why I'm doing this. In red, inside my steps, I said this will eliminate / reduce all denominators. Watch. This is really 5/1. Technically, this is 5/1, but I'm not even going to worry about that because it's not a fraction. And this is 5/1. Notice I have a 5 in the numerator. Let me highlight. I have a 5 in the numerator and a 5 in the denominator. They will reduce. In other words, you can just scratch them out. And you're left over with x. Does that make sense, everyone? Okay? In the second term, you were just left over with minus 5x. There is no fraction there for you to worry about. On the right-hand side, the 5/5 reduce, and you're left over with this numerator, which is a 1. Does that make sense, everyone? Yes or no?
Yes.
Okay, all right. See, what I did in one step is I eliminated all of my fractions. And that's the goal. So if you see fractions, you're going to multiply by an LCD to remove them. So once we're done with step 1, let me use a red marker here because that keeps popping up and it's driving me crazy. There we go. Now it's really driving me crazy. All right. So in one step, we got rid of all of our fractions. Put a check mark next to it. Done. Step 2, if we see parentheses, use the distributive property. No parentheses. Done. Step 3, look on the left. Combine like terms. Well, I have x minus 5x. So that's going to be 1 minus 5, or negative 4. Last name x. On the right-hand side, I have a 1. That nothing combines over there. So now that's done. Step 3. Step 4, variable terms on one side, constant terms on the opposite side. That's already done. Step 5, divide both sides by the number in front of the variable. Divide both sides by negative 1/4. So x equals negative 1/4. Does that make sense, everyone? So we should have a pretty good understanding of steps 2 through 6. We already did that in chapter 3. It's just this new step dealing with fractions that we have to be concerned with. Okay, are there any questions? All right, let's do letter B. We'll do letter B together. So letter B, we have x over 2 equals x over 3 plus 1/2. Step 1, if I see fractions, I'm going to multiply by a number that will remove all the fractions. That number is going to be my LCD. So in this case, 2 is prime, 3 is prime. So I'm just going to multiply those two numbers together. So I know the number that I'm going to multiply everything by is a 6. So let me do that. I take the first fraction, multiply it by 6. I take the second fraction, multiply it by 6. And I take the third fraction and multiply it by 6. How are we looking so far? Are we all on the same page? All right, now, you got to remember, the reason why we chose 6 is so we can reduce the denominator. So all I'm going to ask, in this very first fraction, I know I'm going to reduce the 6 and the 2. So cross out the 6, cross out the 2. In other words, what is 6 divided by 2? Can anybody tell me what that is? So you're left over with a 3x. See, let me rewrite it here. A long time ago, I helped you to reduce fractions. All right? And the way that we did that is we would take this 6 and I would say, okay, we're going to rewrite it as 2 times 3. So then we can see that the 2's reduce. And look what's left over. 3 times x. That is exactly how I got that 3x right there. It's not like I'm doing anything special. I'm just doing everything that I was taught in just little segments now within this problem. Okay? Now, if that's the case, can somebody tell me what this second fraction reduces down into? 6 times x over 3?
2x.
I love it. Very good. And what about the last fraction? The last fraction, 6 times 1/2.
3x.
Oh, no x. Do you see an x in the numerator here? That's okay. That's okay. You were just following the trend. I get that.
Yeah.
All right. But here's what's nice, Kaylee. Oh, I'm sorry, Mike. I didn't hear you.
I said, how do you get the 3x and 2x and 3 again?
All right. So let me show you one more time.
But I was just...
So here's the first fraction. Here's that second. I'll do it for each one of these, okay? Here's that second one. And then here's the third one. All right, so that 6 is really 2 times 3. Do you agree with me on that?
Yeah.
Now, that whole thing is over 1. Do you agree with me on that?
Yeah.
Do you see any numbers that are the same in the numerator and denominator that I can reduce?
2.
So,
Okay.
do you see it now?
Yeah.
All right. The same thing is going to happen here with the next fraction. It's just with this one, the 3's will reduce.
All right.
And then the same thing with the last one. 6 is really 2 times 3. When you reduce it, you get 3 times 1, which is 3. Okay?
All right.
All right. Good. Yeah. So step 1 is done. Step 2, do we see parentheses? No. Step 3, can I group anything on the left? Nope. Can I group anything on the right? No. Step 4, variable terms on one side, constant terms on the opposite side. So I am forced to move this 2x. Since it's positive on the right, I'm going to move it to the left by subtracting. 3x minus 2x is going to be 1x. And then you have a 3 on the other side. So x equals 3. Does that make sense, everyone? See, solving fractions or problems with fractions, I think, very easy. All you're doing is multiplying by an LCD to get rid of all of your denominators. Get rid of all your fractions. If you don't like them, get rid of them. All right. How about you guys do letter C for me? Go ahead and do C. Y over 2 equals y over 5 plus 3 over 2. Whenever you get an answer, just let me know what you get. And if you're stuck, you got to let me know. I can help you.
I think I'm stuck.
All right, Leah. So, step 1, do you see fractions? Yes or no?
Yes.
What was your LCD that you came up with?
10.
I love it. I would agree. So, did you multiply every single fraction by 10?
Yeah.
Okay, so
Wait. Yeah. Sorry.
that's okay. So, is this what you have on your page?
Yes.
All right, so tell me what you got for the first fraction when you simplified.
5y.
I love it. What did you get for the second one?
2y.
I love it. And the third one?
I think it's 3 over 5, but I have not a clue.
No, it's not. So let's write it out, okay? So we're going to come over to here. Now we know 10 is really 2 times 5. Is that correct?
Yes.
Now, we also know this 2 times 5 is over 1. Do you agree there?
Yes.
Do you see any numbers that are the same on the top and bottom?
The 2.
So let's reduce them. So it looks like you're left over with 5 times 3. Do you agree?
Oh, okay. That makes sense.
All right. So you should have 5y equals 2y plus 15.
Okay.
Okay?
Thank you.
Yeah, good mistake. And hopefully, some of us who didn't ask if they needed some help, hopefully that clarifies some things for you now. So go ahead and finish this. I'm going to see how many problems we have left. Okay, good.
just say the answer?
Sure. I'd love to hear an answer, Mike.
Y equals 3?
I think that looks pretty good. Actually, no, you know what? I'm going to disagree with you. I think it's 5. Anybody get 5?
I did.
Yeah, I think it's 5. So let's go ahead. Let's do this.
Yeah, I think I just can't. Yeah.
It's all right. Don't worry about it. So step 1, we got rid of our fractions. Step 2, no parentheses. Step 3, I cannot group anything on the left, and I cannot group anything on the right. Step 4, variable terms on one side. Excuse me, constant terms on the opposite side. So I need to subtract 2y from both sides. That's going to give me 3y equals 15. Step 5, divide both sides by the number in front of the variable to give me y equals 5. Okay? Any questions? Are we starting to see how this works? The flow and everything. All right. So let's do D, and then I think what we'll probably call it a day after this. All right? Because it's already 10:50. And I started like 2 minutes early, so I promised I'd let you out 2 minutes early. So here we go. Step 1. Do we see fractions? Yes or no?
Yes.
All right. So I'm going to multiply by an LCD. What's that LCD? Can anybody see it? Just tell me what it is.
5?
I love it. So here's the thing. You got to multiply everything by 5. Now, we could do something right off the start. Does anybody see what we can do? Say that one more time. I didn't hear you. Sounds like you're not talking into the mic. I think that was Tanisha.
Combine like terms?
Yes, combine like terms. I'm so glad you saw that. So real quick, before we just dive right into the problem, I'm going to highlight the like terms. So sometimes you just, instead of just jumping right in, you want to take a step back and go, oh, well, wait a minute. I got 3x minus 2x on the same side. I know I can combine them because they're the same. They got the same last name, which is the letter x, raised to the same exponent, which is the number 1. So 3x minus 2x is just going to be x. And then on the right-hand side, you have 1/5 plus 2/5. Same denominator, so just add the numerators. 1 plus 2 is 3. Okay? Excuse me. Now, if you wanted to, you can multiply everything by 5, which, since we're learning how to solve by fractions, that's what I'm going to do. So, multiply this by 5, multiply this by 5, and multiply this by 5. So, the 5x, that doesn't change. That stays 5x. 5 times 1/5, the 5s reduce. So I'm left over with a 1. And then on the right-hand side, 5 times 5 times 3/5, the 5s reduce. So I'm left over with a 3. Now, from here, I can add 1 to both sides to get my variable term isolated, constant term on the other side, and then divide both sides by 5 to give me x equals 4/5. Okay?
Couldn't you have just added the 1/5 up top?
That would have been the other way to do this, and yes. So here's what Michael's saying, because I definitely want to go over that. So if you just, and the only way you're going to see this is if you take your time. If you just take your time and you look at this, I could have, just like Mike said, I could have added 1/5 to both sides of my equation. Now, we know when you're adding fractions, denominators must be the same. They are, so what's 3 plus 1, and that's 4. So you still get the same exact result. So Mike, this is where I would say this stupid question that I always say. I go, where do you live, Mike?
Robinson.
I live in Monroeville. If we want to tee off at 4 o'clock, because I know you like to golf, do I care how you got to the golf tee?
No.
No, as long as you're there by what time?
4.
Because that's when we tee off. So if you can see another way to do a problem, then try it. Here's my thing. Make sure that you are just following your math techniques, okay? That's all I can add. That's my advice. Make sure you're following your math techniques, okay? Also, how often do you think this is going to happen where all these denominators just happen to be the same?
Not often.
Not often. So it's always good to know how to use these steps, okay? So on that note, I'm going to stop recording